Okay, so hi everyone, Senan this side, and in this video we are going to see how to detect that if an array of integers which represents the in-order traversal of a BST, is this a valid ordering or not. So given this, in a valid binary search tree, all keys are unique, so we cannot have duplicate elements, that's for sure. The next thing is, if you see this is a valid tree assuming 45 is at the root, and you make just a pyramid shape. So 8, 14, 45, 64 and 100. This is a valid BST, right? And it follows the in-order traversal of this. This might not be the case because whichever you take as the root, so if you take 5 as the root, you would have 1 on the right of it, which is not true. If you have 6, again you would have 1 on the right. If you have 8, again you would have 1, 7 on the right. And if you have 7, you would have 8 on the left. So a binary search tree, wherever is the root, the element to the left of it should be less than the current value, and element to the right of it will be greater than current value. So if you know what is the in-order traversal in a binary search tree, you know that a binary search tree's in-order traversal is a sorted array. So that is what we are going to check. What we are trying to do is just compare the adjacent elements, and if they are not in an increasing order, that means it's not a binary search trees in-order traversal. This is what I'm doing. I get the size n and I go till n minus 2, I is equal to n minus 2, and I compare if array of I is greater than equal to array of I plus 1. Why equal to? Because all keys are unique, right? So in on the case of equality, we need to return false as well. So if the first element is greater than the next element, that means we have disturbed the sortedness of this array, so we return false in that case. Otherwise, if we were able to go through the list without having any issues, that means the array is sorted and we return. Let's look at the notebook and see what I'm trying to say exactly. So given this tree, how do you get the in-order traverse of any tree? You just mark sticks like this. That's what I saw. I just know this technique, but I don't remember how I got the technique. Did this years back. And what you do is go through like this and just touch. So every stick you touch, that is a part of your in-order traverse, right? Now you see the order. So what is the order? It's first 25, 30, 32, 35, then 40, 45, 50, 60, and 70. Clearly, you can see this in-order traversal of this tree is, this binary search tree is a sorted array. So this is what you had to check, and yep, that is the whole video all about. Hope this was helpful in some way, and yeah, thanks for watching, and I'll see you in the next video.